Today we'll be giving weekly contest for 470, and I'm going to give this contest as a virtual contest because I wasn't able to appear in it, and I have not been giving contests lately. This is a contest that I'll be giving after a long time, so yeah, let's see how it goes. And I'll be solving the problems live, so I might face some issues because I've not been giving the contests. So yeah, let's just see how it goes. I am not going to explain the problems as I solve them. I am going to explain them after I'm done with the contest so that I can actually give the contest in a contest way. So yeah, let's go. So I'm going to start it, and this will open A for us, so we'll just open the rest of the problems. Okay, compute alternating sum. So we are given an integer array nums and the alternating sum. Okay, I just need to return the sum. So it should be alternating. So what I'm going to do is I'm just going to iterate through nums, and then I'm just going to do sum plus equals nums of I times, if I modulo 2, then we'll do a minus 1, else we'll do a 1, and then in the end we can just return sum. So I think that should work. Minus 4, and the other one should be 100. Okay, there we go. This was an easy one. So longest subsequence with a non-zero bitwise XOR. So we are given an integer sequence nums, and we have to return the length of the longest subsequence in nums whose bitwise XOR is non-zero. All right. Okay. So one thing we can do is, yeah, this is an easy problem. So basically the thing is that, let's just say, oh, I'll explain it afterwards. Yeah, I'll just solve it for now. So we're going to take the XOR of x, and then we'll just return. If XOR is 0, then we'll return, else we'll return exercise. I hope this works. I don't have a proof. I'll explain this problem. Oh, okay. Interesting. Oh yeah, sure. This is an edge case. Yeah. Okay. You can just do a count. It should work now, I believe. Yeah. Remove k balance substrings. So basically we have a string s consisting of open and close brackets and an integer k, and a string is k balanced if it is exactly k consecutive, these followed by these. You must repeatedly remove all the non-okay. Alright, so it's also an implementation problem. Let's just keep. So we are going to formulate basically an integer and a character. So the character is basically the last character that we have in our stack, and integer is the count of that character. So what we are going to do is, I'm actually going to use size now. So we'll iterate through the entire the entire string, and then we'll just see that the current character is s of I, and then we'll just see that so what we'll do is that if the stack is not empty, and the last character, so basically st.back.first is equals to the current character, so what we are going to do is we're just going to increment the second value by +1, Okay, else we'll add this new element inside our stack, and we'll do that by just pushing this, because this is the first one that we are seeing. And then we need to remove the elements. So yeah, so in order to remove them, what we are going to see, so basically we're not going to remove everything we see, but we are going to do this in a while loop. So first of all, obviously this should not be empty, and what else should we have? Okay, so yeah, so we are going to remove it, and actually the size should be greater than 2, you know, it should be greater than it should be greater than equals to 2, because we are going to remove the last two elements. And we'll just see that if st of st dot size minus 1 dot, okay, so it should be minus 2 dot back dot first is equals to the open bracket, and st of st dot size minus 1 back dot first double equals to a closed bracket. Then we are going to remove them. And how do we remove them? We'll calculate the minimum of st of st dot size minus 2 dot back. We don't really need a back here. Why am I adding a back? Can just do a first, okay, and then we'll have the second one, which is basically st dot back dot first. So this is the minimum, so basically we are going to decrement both of them by the minimum value, minus 1 by minimum, and then we'll just see that if st dot back dot first double equals 0, then we'll just st dot pop, right? And again we have to check if st dot back basically if it should not be empty, obviously its size is greater than that. So we'll just see that if st dot back dot first is 0, then we again do a st dot pop, because the closing bracket might also close. Otherwise, if it's not closed, then we just do the operation like that. But it also might happen that okay, so it might happen that we do the pop, yeah, that we do the pop, but the previous to previous element, so that means the open bracket gets to a value which is 0. So then what we have to do is basically we'll create an else condition. If it is 0, then we just remove both of them if it's possible. Otherwise what we are going to do is, okay, so if it's not 0, then what we are going to do, we are going to basically what we are going to do is we're going to check that if st of st dot size minus 2 dot first is am I doing it right? It should be second here. I should be doing a second here, because we have to see the frequencies. So if the last to last element is it is 0, then we have to pop it. So how can we pop it? So basically we can just we can store the current st of st dot size minus 1 as that, and then we can do st dot pop, and we can do st dot pop again, and then we can just see if the stack is not empty, and then st dot back dot first is equals to our opening bracket. No, it is equal to our closing bracket because closing bracket is still there. So what we are going to do is we are just going to add this value to the second one. So that's p dot second, I think. Otherwise we'll just st dot push p. Yeah, so I think this should be the correct way to do it. And we're going to form our string. Let's just call it answer. We'll just iterate through our through our stack, and we are just going to iterate throughout the length, and we'll just do answer plus equals x dot first, or basically we can just do this. We can do answer plus equals string of x dot second comma x dot first, and then we can just return our answer. I think this should be it. Oh yeah, it should be a push back. Rather, I've used push. There we go. Yeah, okay, it should also be a second here, and yeah, now it should work, I think. Okay, we have to pop back. Okay, so our output is this, which is not expected from us. So let's see what happened. So we are seeing the current element, and then we are adding it to it. So yeah, so it is equals to the current element, so we add it, and then we just check if the size is greater than or equals to 2. Okay, and then we just check that if the first one is that and second one is that, we do this. So basically the size becomes like this. And wait a minute, yeah, this is fine. Okay, so it's like that, and then we do the minimum. We subtract, we take out the minimum, we subtract the minimum from both of them. We can just print out the index. No, it's just tell us what implementation errors we made. Okay, it's not even. All right. I think my character is fine. Oh, we have to only remove k balance substrings. We need to check also, right? Yeah, we need to check that condition also, that basically st dot size minus 2 dot second is greater than equals to k, and st of st dot size minus. Oh, then we have to remove the division. Cool, so we have to basically divide this by k then, because that's how many we are going to remove, and then we can just do minimum times k, here. All right, yeah, things, yeah, that's it. But okay, that doesn't really make this problem hard. That's just. But why isn't it going inside the loop? Is it even going inside the loop? Okay, let's just print out C and see what happens. I think it is entering it. If it is not empty and the back, otherwise we push it. So we can print out I here. Yeah, so it happens on a 0 and also happens on a 2, so, which is fine. Oh, what the hell happened to me? This okay. Yeah, this will be only 0 or 1, so it will never be greater than 2. I need to remove some logs, or I'll just comment them. Might become useful later. So this is empty. This is double slash. This is that. Okay. Let's see. Let work. This is a lot of heavy implementation, but it did work, so it's fine, I guess. There were a lot of edge cases in here, but yeah. So this is the last one. Count no zero pairs that sum to n. Okay, no zero integer is a positive integer that does not contain the digit 0 in its decimal representation. Okay, given an integer n, count the number of pairs a comma b that such that a plus b equals n. This is digit dp. So we need to find the number of pairs that equals to n. So how can we formulate this? So thinking about it, the first thought that came to my mind was obviously digit dp, because this problem actually screams digit dp because of the constraints. Okay, let's see how we can do this. So let's think. So so it's obviously going to follow up a normal digit dp sequence. So yeah, so it will follow up a normal digit dp sequence, but the thing is that we don't have a range this time. We need to find out the number of pairs a plus b such that they are equals their addition is equals to n. So obviously we can't brute force we cannot check them in a brute force way, so we have to look at the decimal, the decimal addition, or in a way we have to look at how the bits move, right? So the thing is, in here, every time we do. Is it raining? Yeah, it's raining outside. Oh, okay. Let me see. I'll be back in a second. Yeah, it's raining heavily. Anyways, we're just going to solve the problem. I don't really care. So yeah, we have to look at the addition bit by bit. And why do I say so? Well, I believe that we cannot, you know, yeah, this is simple because we cannot look at every single integer. We have to look at the addition bit by bit, but there will also be some carries that will be coming forward from the right side, right? So for example, in this case n is 11, right? So we can have 4 plus 7, and the one thing is that we only need to count unique pairs, because we can basically double them. And also it's a good way for us to do this in a sorted order. So also this should not contain the digit 0, right? That's a lot of requirements, but let's just see what we can do. So n is 11. In its binary form, we can write this as 1 1 0 1, right? And a equals 4, we can write this as 1 0 0, or basically if we match the bits, we can write this as 0 1 1. Oh, 0 1 0 0. And b is 7, so we can write 7 as 0 1 0 0 1 1 1. So how do we know that this their addition? Well, basically if we try to do the addition, right, we'll have 1 plus 0, which is 1. We'll have 1 plus 0 again, which is 1. And then we are going to have, wait, oh, it should be this, my bad. So we're going to have a 0 here, and then that 1 gets carried over to the next bit, so we're going to have this. So we can see that in bits addition, we are just going to carry forward some values. But how do we check that they don't contain a 0? That is an interesting problem in itself. Well, there has to be some way to check. How can I think about this? Okay, so how do we check if it contains a 0? That's an interesting question. Yeah, let's see. Sorry, I was writing something in my notebook. So let's think about it. So what do we know about the the numbers that have 0? Let's try to think in that way. So let's just say it's 40. So 40 is, we need a 32 bits, so it would be 1. Then we also add a 16, so it would be 0. No, we don't add a 16. We want an 8. So we add this, and then this is our 40. Let's write 30. So for 30 we don't need this bit, but we need this bit, so it's 24. Then we add another 4, which is this and this and this. So obviously all of them are even, so the last bit will be unset. Let's think about 20. So 20 will be this, 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 this. Let's think about 10. 10 will be this. Let's think about 50. 50 will be this, 48, and then this. Let's think about 60. 60 does contain a 32. I think it does, yeah. So it's this, 48 plus 8, 56. 56 plus 4, and then this. So an interesting thing about values of 10 is that well, the obvious thing is that the last bit will be 0, so we don't need any number with the last bit 0 and some continuous amount of bits. So I cannot see a pattern really here, but there is no pattern here, so you cannot really see any pattern. Okay. So if we see digits, um, we can only move from right to left, but there will also be a carry. mm, how many digits does a number needs to have for? Well, 3 plus 57 is also 60. So it's not necessary that both of them have the same number of digits. It's never necessary. But regardless, we can just try out at every position. So how do I calculate the positions? Well, if I can just convert it into a string, and then we can easily have, so these many positions we are going to consider, and we have to consider each and every digit from 1 to 0 or 1 to 9, because we cannot consider 0, otherwise that would hmm. So let's try to define some state. Maybe trying to code will give us an idea, but we might end up wasting time. Okay, let's think about this. So let's say we are doing a digit DP. The things that we need to consider. Let's just try to think about this. So obviously we are going to consider the length of the string. That is something we always do. Length of the string, which is basically the number of digits in n. We can also find that out by dividing by 10, but this is also the same thing. We have to convert it into a string anyways. And then what we need is so if I run, okay, here's the thing. So if I run 2 loops to perform an addition for the current index, let's just say that current index we are considering in n is, I don't know, something like 7, and if I do an addition, so that addition will be the current a id, basically index that we are considering inside our length of the string. That will be current b of index, and let's just say that they were plus we can also have a carry. So yeah, so we also need to consider a carry because it can come from the previous addition that we did. So for example, before this we had an 8 and we did an addition of 9 plus 9, so it will lead to a carry of 1 to the next index, and that will be equals to n. So but what about the cases such as 003 plus 50 03 plus 57? We have to do it like this, right? This is also a way. If I don't consider 0, then so maybe I'll let's just create two more states. I think then we have to create two more states of, let's just say, UA and UB, which means that we have used a 0 in A or B, and if we have, then that's an invalid state, and we won't return a 1 when we end the loop. So in this way we can probably do it. And also the carry should be 0. Okay. Um, but we cannot start with a 0 from the first index, otherwise that will be an invalid number. How can I do this? Okay, so in order to take care of the carry, first of all, let's just reverse this. Why am I reversing this? I'm reversing this because you know then we won't know what the previous carry was if we start from the front of addition. Like if we start from 0 and 5, and then if let's just say that instead of 0 and 5 it was 9 and 8, uh, so how do we know that one needs to be carried backwards? So that's why we do a reverse, so that we know what carry will be carried forward, just like normal addition. We always do it from the back, so instead of doing it from the back we just reverse the string. But then also reversing, we cannot keep the first index as 0. So let's form like a skeleton for this. Maybe let's just say int dfs, that's what I call. So we will be needing an index, um, and then we will be needing two states, ua and ub, which tells us if we have used a 0 or not. Because if we have used a 0, then we need to return a 0. We can directly return a 0 by defining the limits inside our loop. Other than this, we also need, I think this is it. Other the arrays and all that stuff we can just add. So if the index is equals to n, okay, we also have to make a state for carry, right? And obviously the carry will be in between 0 to 9, so we don't really have to care about the memory limit exceeding. So we just need to return the carry should be greater than 0. If it is greater than 0, then obviously, wait a minute, it should be greater than 0 or equal to 0. Oh yeah, it should be equal to 0, because we don't add a carry when we end the addition. We should not have a carry. Otherwise, if the state of dp has already been calculated, then we just return dp. Okay, and other than this, we can create an answer variable, and then we can iterate from let's just say left value of a, which is equals to some temporary a, and left value of a runs from temporary of a to temporary end of a, and la will increment it. Similarly, we'll do it for lb equals temporary of b, and lb is less than equals to temporary of b, temporary end of b, and we'll just do l plus plus, and then we'll formulate a sum which is equals to la plus lb plus also the carry, and then the new carry would be some modulo 10, and then we can just add our dfs to index plus 1 and some state of ua and ub. We can create a temporary ua and temporary ub, and then we can add a new carry, and then in the end this is equals to dp of index of ua and ub and carry, which will be equals to our answer. So now how do I need temporary of a like this. I need a temporary of b, temporary of b like this. I also need a temporary of ua and temporary of ub like this. Okay, so how can I actually calculate this? Basically, also we need to, yeah, we cannot just count this. It should be equals to uh, sum modulo 10 should be equals to the digit that we have, so it should be equals to s of index. Then only we continue, right? We can just do this, but how do I define these 6 variables? mm Okay, so this can be defined inside only because this depends upon the digit. So temporary of ua is ua, and then we do we can just do yeah, we can just or both of them. If LA is 0, temporary of UB is also UB or VC and LB, which is 0 right now. But how do I calculate these 4 values? So this is the starting point for the second value, right? SP. So let's think about this. Okay. Well, starting value only considers 2 things. The TA and the TB only considers that the index should not be 0, because if the index is 0, then we can have them as only 1, because then we won't be able to remove them. And by removing I mean that let's just say that if the current index is 0, so current index 0 means that that index is the last index of our string, or basically n. So let's just say that the current index, if we try to choose it as 0, either in TA or TB, then we won't be able to change it. Why? Because it won't carry forward, right? But it might lead to some wrongs. Oh man. How do I know where it? Well, you know what? We can just run them from 0 to 9. And what we can do is we can check it here. This basically means UA should be 1 and UB also should be 1. And now I'm going to pass in the other parameters, which is n. We have a string s. Do we need anything else? Yeah, for DP I can just define the DP here. I don't really care. So we have an index. So index can be 15 digits. So I'll just make it 16 or something. Maybe 17. u and ub are boolean values, so it would be 2 2, and then we can have a carry which can reach from 9, so I'll just make it 11, and I think that's all. We also need to set the dp, so we do this, we run this, run that, and then we can just return tfs starting from index 0, ua is 1, u is 1, carry is 0, we have nn, we have ns. Does this work? Oh, okay, cool. Yeah, then I'll just make this m. Okay, I need to pass in some values here. This is going to be n and this is going to be s. Zero, zero, zero. Oh my god. Well, we can have the dp here. It's coming out to be 0. If it's probably some of these cases, how do I even handle them? I cannot just is it even running? I mean, it is running. You can print out the index to see how many times it ran. So it ran a decent amount of times for one value only. But still, okay, what can we even do now? Carry is 0, that is 0. Oh, it should be a oh, okay, I got it. We should pass in a false here, because initially they don't. Yeah, this is a true positive case, right? So they should be. We should not have them, right? This is also. What if I do a check of starting index? Okay, if the id is 0, then we have to start with 1, else we have to start with 1. If the index is 0, then we have to start with 1, and we start with a false negative value. 0, 0 and a 0. Okay. This is tiring. Okay, let's just do this. Let's see what our s is. Okay, s is 2, 3 and 11. That is fine. So then we run our dfs, which is 0, 0, 0, 0, which is fine, I guess. It should be 0, false, false, and 0. And then we have an mns. We pass in the mns. We are seeing the index, which we don't need actually. We're seeing if they are equal or not. Yeah, I mean, okay, we can save some computation here by saying that, hey, let's just make this what if I just directly do it here, that if it is true, then we just do a 0 and else we do a 9. That basically means that if we have that, then we do that. If we have, yeah, that doesn't really help us. Okay, so carry should be 0. That is one thing. Our index should be equals to n. Okay, if we have a value, then we return it. Otherwise we formulate our answer with these values, so they are just starting points for us. If it is 0, then we start with a 1, and if it is done, then we start with a 0 in order to avoid it. And then we calculate the sum for us. So sum, we also include, we have a new carry, then new carry. Oh, the new carry is actually this is what we carry, right? So instead of these two loops, I can try out everything. This reduces our chances of problem being wrong. We'll make a false positive case inside our, let's just make a false positive case here that both of them should be positive. 0, 1, 11. This should be 2 here. Yeah, maybe we can just keep this thing going, because this is an important thing. The first ID that we are starting with, it should be 1. Okay, this should be index here. First index we're starting with should be 1. Well, then I think it should be like this. This is just same as this, only we are basically, but then we also don't consider the case when it's 0, right? That's what is happening here. Carry should be 0. These should start like this only, or there should be 9. Does this make any sense? We have 8, we have 1, we have 2. 55 is a runtime error. Do we need to mod something? How is it a runtime error, bro? Oh, the answer can be long. And that just means that our TP should also be long, and so should our DFS. Right. Let's see. Oh, it got accepted. Alright, it got accepted, so that's nice. Now I will just explain these problems. Okay, so the first problem says we are given an integer array nums, and the alternating sum of nums is the value. Hmm. All right, so yeah, so the first problem says compute alternating sum. So we are basically given an integer array of nums, and the alternating sum of nums is the value obtained by adding elements at even indexes and subtracting elements at odd indexes. So this is a simple problem. We just have to see that if the index is even, then we add them, or otherwise if it's odd, then we subtract them. This can also be done in a way, basically. Yeah, this is, I think this is the easiest way to do this. One more way is to just yeah, this is the easiest. So just iterate through the for loop and then just check if the current index is even, then we add a -1, or otherwise add a +1. Basically add the value, and if it is odd, then we subtract the value. So that's just it. So the second problem was longest subsequence with non-zero bitwise XOR. Okay, so this is an interesting problem, as you can see here. It so let's just consider a case normal. So let's just say that after after calculating, I will use this once maybe. Yeah. So let's just say that after calculating the XOR, the value is greater than 0, then obviously the answer is equals to the length of the array, because it's a non-zero subsequence and it has the maximum size. But let's just say that XOR of the array is equals to 0. So that means that uh, all the bits, that we have, all the bits, let's just say that all the bits have even frequencies, then only this can happen. So for example, let's just consider a bit. For example, this case, we have this, then we have this, and then we have this, then we have this. They have odd frequencies, my bad. So if they have odd frequencies, all the bits, so that means the XOR value will be set. So if the XOR value is set here, then that means that let's just say that I remove this number from the array. I don't add this in the sequence. So that means oh, my bad. So if the XOR of array, we have even frequencies. So let's just say that I remove this element, right? So basically I have this, and then I have also one more one. So let's just say that I try to remove this element from the sequence. So if I remove this element from the sequence, we'll know for sure that this bit will be set. So this bit will be set, and if this bit is set, then XOR of our array will never be 0. So that's basically it. So if the XOR of the array is basically 0, then the answer is the size of array -1 for the element we removed. And there is an edge case which I got stuck on. So basically let's just say that the entire array consists of only zeros. In that case, it's not possible to do that. So we need to create an extra check, which is basically this. So yeah, this was the problem. This was a good problem. Yeah. So next problem, remove k balance. So so basically what we had to do in this problem is that we have to remove k balanced substrings. So what are balanced substrings? Balanced substrings are basically balanced parentheses. It's what they are, and we have to remove exactly k consecutive. So I just did what the problem asked. I first of all I created a set. So this set basically consists of a pair of characters and their frequencies. So let's just say that our set stack was not empty and the last element on the stack was an open bracket, and we also find out that the current element that we are considering is also an open bracket. So I just increased the frequency of the open bracket to 2, and otherwise if it was a closed bracket we just added the new bracket inside our stack. But then we have to do also a check that if the size of the stack is greater than 2 and the first and the last element of the stack is an open bracket and the element prior to that is the last element of the stack is a closed bracket and the element prior to it is an open bracket, and the frequencies are greater than k, because that's what they have told us. We have to remove k balance parenthesis. So what I did was I calculated the basically the division by k. So this gives a multiple how many times we have to remove it, because we cannot do it brute force, so we just remove it the highest multiple, and then we just check that if, let's just say that the number of closed bracket we have now are 0, so we obviously remove them, and it also might occur that the number of open brackets we have are also 0, so we also remove them. But if the number of closed brackets that we have are not equal to 0, it might happen that the number of open brackets we have are equal to 0. So basically we just remove the number of open brackets. So this removes the open brackets and this removes the closed bracket, and then we just check that if after removing the open bracket and the closed bracket the last element the stack is not empty and the last element of the stack is a closed bracket, so we just add the frequencies. Otherwise we just push back the closed bracket that we popped out, and then we just form the answer in the end. So this was an implementation problem, and it had a high scope for you know the implementation issues, but yeah, it worked for me. Yeah, that's all about this problem. This is just implementation, do what they say. Okay, so this problem was a digitdb problem. So what we did was basically form the states as we are solving the problem. That helps a lot in these kind of problems. So our DP consists this DP is basically the index, two boolean values, which means if we have used 0 in either A or B, and then the last thing is basically the carry that we are carrying. So first of all I converted n into a string and then we reversed it, because that would help us carry the carry forward. So I reversed it and then I did my DFS. So what my DFS basically does is that if we are at the end of the loop, it just basically checks if we don't have a carry, because if we have a carry then this will basically form a number which is not n. So now what we'll do is that if we have a carry, so we'll iterate through our from 0 to 9, but we don't really iterate from 0 to 9. Why is that? Because let's just say that we are on the first digit. Okay, so first digit means that the last digit of our current number n. So that would mean that if we are iterating from the first digit, which is the last digit of n, and if it is a 0, then we have no way of converting that number to certain value, so we just start from 1. And similarly, if we are ending to a current digit, this check basically what it does is it prevents us from going further. So we choose a 0, but we don't go any further because of the fact that it is a true value. So these are basically bounding conditions to our range, and they are similar for both of them because they are almost identical, because we can change a and b, right? 4 plus 7 and 7 plus 4 are same thing. So that's what they are doing here. And then what I'm doing is I'm calculating the sum, which is equals to the current digit for A, current digit for B, and the carry that we are carrying, and then we calculate the new carry, which is let's just say that if it was 19, so we do a 19 by 10, which is a 1. So we carry a 1. I was doing a modulo before, that was wrong. That was actually the digit that we have on that index. And then we calculate the new values for these, and then we pass them inside our loop, and then we do this for everything. And yeah, so this was a good problem. I think the bounding conditions gave me the most issue, but it's fine, I guess. So yeah, that's all for this. This was a good digit DB problem. And I feel like doing digit db problems, the best way is to form the solution as you write the code, because then you can be more sure about the conditions that you want inside your dp. As you are writing the code, you realize that, oh, I need this, so I add this to my dp. And this can be done in digit db because we have a lot of you know we have only 15 digits at max, or maybe 18, so we can do a lot of stuff. So yeah, that's all for this. This was weekly contest 470, and yeah,